All right, let's dive in. You ever feel like the terms artificial intelligence, machine learning, and deep learning all just get thrown into a blender? Yeah, you're definitely not alone. So today, we're going to untangle all of that and break down exactly what separates these amazing technologies. Let's get to it.
Okay, so this is really the core question, right? We hear these terms used like they're the same thing all the time, but they're actually separate, really important evolutionary steps in how we build smart machines. And getting your head around this difference is the key to understanding where all this tech is really going.
To help us out, think of this as our map for the whole explainer. The best way to picture it is like a set of Russian nesting dolls. We're going to start with the biggest doll, which is artificial intelligence, and then we're going to open it up to find machine learning tucked inside. And from there, we'll zoom in even further to find deep learning. And finally, the newest arrival on the scene, generative AI.
So, first step, the AI universe. This is the oldest, broadest concept of them all. It's the grand vision that has captured the imagination of scientists and storytellers for decades, the idea of teaching machines to think.
So what is artificial intelligence? Well, it's the big foundational idea. It's the grand ambition to build machines that can reason, that can learn, and that can solve problems just like we do. It's really the whole universe of trying to give technology a mind of its own.
But here's the thing. Trying to write a specific rule for every single possible situation a machine might encounter, it's basically impossible. And that massive challenge is what led to a huge breakthrough, a totally new approach within the world of AI.
And that breakthrough, that's machine learning. Now, this was a fundamental shift. Instead of giving the machine a giant rulebook, we just feed it tons and tons of data and let it figure out the patterns for itself. Think of it like this. It's the difference between giving someone a fish versus teaching them how to fish. And here's the wild part. You are using this stuff all the time, probably without even thinking about it. Those movie recommendations that Netflix gives you, the fraud alert you get from your bank, even the way ads seem to follow you around, that's all machine learning in action, learning from what we do to predict what we'll want next.
Okay, let's make this super concrete. Think about Google Maps. It doesn't just have one map saved somewhere. Step one, it's constantly grabbing live location data from phones just like yours that are out on the road. Step two, it's comparing that live data to tons of historical data, what traffic is usually like on a Tuesday at 5 p.m. And then, step three, it combines both of those things to predict the fastest route for you right now. That's machine learning, and it gets better and better with more data.
But machine learning kind of hit a wall when it came to really complex, messy, real-world stuff, like trying to tell the difference between thousands of unique faces in a sea of photos. The old models just couldn't handle it. The problem was just too big. We needed another leap forward. And that leap? It was deep learning. The solution wasn't just about more computing power. It was a completely different way of thinking. An architecture inspired by, you guessed it, the most complex machine on the planet, our own brains.
And this quote just nails it. Seriously, think about how a little kid learns. First, they just see basic shapes and colors. Then they learn to connect those shapes to form an object, like a round thing is a ball. Then they learn a concept associated with it, like bouncing. Each new idea is built on top of the last one. Deep learning works in exactly the same way, using layers. So the key takeaway here is that deep learning is a special kind of machine learning that uses these things called multi-layered neural networks. The whole design is meant to mimic, in a very simplified way, how the billions of interconnected neurons in our brains process information.
So how does this neural network thing actually work? Well, you've got data coming in on one side, that's your input layer. Then it passes through all these middle layers, the so-called hidden layers. And it's in these middle layers where the magic happens. The network learns to recognize simple things first, like edges and corners. The next layer combines those to see shapes. The next layer combines those to see things like eyes or a nose. And finally, the last layer, the output layer, makes a final decision, like, yep, that's a cat. So why is this layered approach such a game changer? Well, because the real world is messy. It's not a straight line. Simple problems, like the one on the right, can be solved pretty easily. But real-world data, like what you see on the left, is all over the place. These neural networks are designed to navigate that kind of chaos, to find the hidden patterns that we could never spot on our own. And this layered approach is what unlocked all the stuff that used to feel like pure science fiction. The Face ID on your phone, the Alexa or Google Home in your kitchen, the incredible AI that helps doctors spot diseases earlier. And yeah, the incredibly complex brain inside a self-driving car. Deep learning is at the heart of all of it. All right, so now we get to the very last nesting doll, the newest kid on the block. We've gone from teaching a machine to recognize something to helping it understand that thing. But this latest evolution, it isn't just about analyzing what already exists. It's about creating something that has never existed before. And this is the big fundamental shift. Until very recently, pretty much all AI was about analysis. It would look at a bunch of data and make a prediction. Generative AI, it's a totally different game. It looks at a bunch of data, learns the underlying structure of it, and then it generates something brand new and totally original in that same style. So here it is, our final nesting doll, generative AI. It's this cutting-edge branch of deep learning that moves beyond just prediction and into full-blown creation. This is the engine behind all the tools that can write an email for you, compose a song, or create an unbelievably realistic image just from a few words you type. Now, to give you a sense of the just mind-boggling scale we're talking about, what's this number? 1.7 trillion. That is the estimated number of parameters. You can think of them as tiny little adjustable knobs for learning inside the GPT-4 model. Just for a little perspective, the human brain has about 100 trillion synapses. It's this absolutely massive scale that lets these models create such nuanced and, well, creative things. So if you look back at the journey we just took, you can pretty much sum up the entire evolution right here. We started with this dream of teaching machines to think. Then we figured out how to let them learn from data. After that, we gave them an architecture modeled on a brain, and now finally, we've sparked their imagination. And that leaves us with one final big thought. This last step, this jump from simply understanding the world to actually creating things in it, that's arguably the biggest shift of all. It changes our entire relationship with technology. So, as these tools get more and more powerful, the real question isn't just what can they do, it's what will we ask them to create next?